Hi, Algebra 2. This is our first video for Chapter 2. This first section is called Relations and Functions. Our goals for this video are to analyze relations and functions and to use equations of relations and functions. First off, a vocab word that we've already defined, but I want to define it again because it is important. What is a function? This is a relation in which each element of the domain, which is our x values, is paired with exactly, that's our key word there, exactly one element of the range, which is our y values. So, sometimes relationships are functions and sometimes they're not, depending. So, let's take a look at some examples. Here's one example, I have a little graph here, state the domain and the range of this relation, and then I ask, is it a function? So, let's assume that each of these guys over here is 1 unit wide. So this would be 1, 2, 3, 4, 5, -1, -2, -3. And then that would be along our x-axis. That's our domain. And then on our vertical axis, again, I have 1, 2, 3, 4, positive. That's my range coming into play. And then down here, -1, -2, -3. So what is my domain and my range? My domain, I'm going to list off some points here. So I see I start all the way over at -3, and I have a -2, a -1, a 0. I have a +1, and I have nothing at 2, and then 3 and 4. So that is my domain. What x values do I have? And then let's talk about the range. I'm looking at my y values. I'm going to start low. I see I am down at -3 to start. -2 is next. Nothing at -1, nothing at 0. Then I have some points at a height of 1, a height of 2, and a height of 4. There we go. Okay, so then the question is this a function? Is this a function? Well, again, the definition is each x pairs with exactly one y. And I see a problem here. This point versus this point. This ordered pair is going to be -2, +1. And I also have -2, -2. So that has the x value of -2 being paired with more than one y value, and that's not okay. Therefore, this is not a function. Simple as that. Cool. All right, let's keep going. The vertical line test could have been helpful for us in this last example. Hopefully, you remember the vertical line test. Here's an official definition of it. The vertical line test is the visual test to determine whether a relation is a function. Here is the test. If no vertical line intersects the graph at more than one point, then the graph represents a function. So here's an example. Let's say I'm doing my thing. I have a graph. An example of a function that will pass the vertical line test, passes the vertical line test, would be something maybe a little crazy, but it still passes. Look at that. At any given instant, a vertical line only passes through that graph one time. Therefore, it is a function. However, a non-example, which fails the vertical line test, is maybe something like that. That's a problem, because I see there's a couple instances where a vertical line crosses my graph twice. So that one is not a function, but this one on the left is. There we go. So, for example 1, we could have used the vertical line test. Right here, I see if I drew my vertical line, I do hit that point, both of those points, in the same vertical line, so that's a problem for me. Okay, let's keep going with some more functions. Let's take a look. Page 2. Here we are. Okay, there we go. I would like us, for example 2, to graph y equals 1/2 x minus 3. Determine the domain and the range, and then I want to know, is it a function? So let's take a look. A good way to work on this is to give me an x and y table to figure out some ordered pairs that I could use for this graph. Again, let's assume that each one of these is 1 unit tall and wide. So when we do an xy table, I recommend some negative numbers, try 0, and some positive numbers. That gives you a good domain to work with, a good amount of x values to try. So 5 points is usually good. I'm just going to stick with those guys. So what I'm going to do is plug in each of these x values one at a time for this x, and I'm going to chug out a y. Think of your function as a machine, or whatever the relation is. Think of it as a machine. You are putting in the raw material of x. The machine turns it around and produces the y value, a new product. So here we go, plugging in -2. I get y equals 1/2 -2 minus 3. I have -1 minus 3. I have -4. So -4 it is. I have, plugging in -1, I get a -1/2 minus 3. So I'm going to have a -3.5. Sorry there, letting the puppy dog outside. So I have -3.5 or -3.5. Plugging in 0, let me just section those off a little bit. I have 1/2 of 0 minus 3. 0 times anything is just 0, so I get -3. Okay. Plugging in 1, and I'm doing these kind of fast because I know that you guys can handle this order of operations, simplifying pretty well. I have 1/2 minus 3, so I'm going to have -2.5 on that one. And the last one, 1/2 of 2 minus 3, I get 1 minus 3, I get -2. Lovely. So we are going to plot those points and see what kind of a shape we get. So -2, 1, 2, -4, 1, 2, 3, 4. -1, -3, and a half. Roughly right there. 0, -3. 1, -2.5, 2, -2. Notice these are not perfect boxes. I just drew this for the sake of the notes here. Usually graph paper is a lot more precise than this. I see I am getting a nice line, so I'm just going to sketch that line right there. Nice line. So what is my domain? Thinking to yourself, was there any x value that I couldn't plug in? And hopefully you're saying to yourself, no, I can plug in any x value that I want. Any x value that I want. I can take 1/2 of anything. I can subtract 3 from anything. So I'm going to say my domain is all real numbers. You could also just use the scripty or the fancy R, which means all real numbers. So I can plug in anything. And then take a look at our graph. This is a line. And I drew these arrows on it, which means the line keeps going forever and ever. On this side it goes higher and higher and higher and higher. On this side it goes lower and lower and lower and lower, meaning I'm going to go through all of the range values too. So my range is also all real numbers. And again, you could use the fancy R to show that as well. Last part, is it a function? We see that as I go through, at any given instant, a vertical line is only going to cross this relation, this graph, at one instant. Therefore, it is a function. There we go. Alrighty, I'm going to stop the video at this point, and we're going to continue in the next video.